Good afternoon, everybody. Welcome to this massive session. You are a little bit intimidating, I have to say, but I have the lights, so I don't see you, so it's a good thing. So my name is Max Erdica. I know some of you, I already met you. I'm a principal engineer working for the data center business unit. I've been working on ACI pretty much from the beginning, focusing mostly on the topic of interconnecting ACI data center. Before ACI, I was doing interconnecting data center using OTV, so DCI has been a topic for the last 5, 6, 7 years for me. What we're going to talk about today is ACI multi-site, okay, which is one of the architecture part of the ACI Anywhere umbrella. You must have heard this morning the announcement of integration of ACI with the public cloud. We'll talk about what are the architectural components of this ACI Anywhere story, but the focus of this session is specifically on the ACI multi-site part. Here with me there is my friend and colleague John Weston, who is going to handle every question that you may have on the WebEx room. I think it's called WebEx room now, or Spark room, whatever they're called. So if you're shy to talk in front of all these people, ask the question and John will reply in writing. If you're not shy, raise your hand and the ladies at the end will bring you the microphone, right? So that everybody can hear what you're asking. So as a minimum, I would fail completely if when you walk out of that door, you don't have a better idea of what ACI multi-site is. And now, can you actually compare that with ACI multi-pod? What use cases you use one versus the other, right? Why do we multi-site versus why do we multi-pod? I'm not going to talk about multi-pod in detail. John has a session tomorrow. We'll talk for an hour and a half about ACI multi-pod. But at least I want to frame the conversation for you to basically clarify when multi-pod makes sense versus when multi-site makes sense, okay? I assume that you know what ACI is. If you don't know what ACI is, you are in trouble. You can sleep there for a couple of hours. I will keep talking and you sleep even better, and it's not a problem, right? I won't take it personally. I have one slide to tell you what ACI is according to Max, but other than that, there is some assumption that you know, right, what I'm talking about. In terms of agenda, I'll do a quick introduction about ACI, as I said, and about the ACI Anywhere story, and then we'll dive into a multi-site deep dive, right? Just a quick refresh of multi-pod so that we can frame, as I said, the conversation about the use cases and when to position one versus the other. So, first, the one and only marketing slide is this one, right? It's an update, it's the State of the Union, right? Trump didn't do the State of the Union, so Max is doing the State of the Union. For ACI, we have now almost 6,000 customers, and we basically crossed the threshold of 50% of Nexus 9K deployment being ACI mode versus standalone, which is good, but it also means that we still have a massive standalone deployment, right? And if you're interested in the multi-site solution for standalone, which is VXLAN multi-site, you can come tomorrow morning. Myself and Lucas Kratiger will present that at 8:30 a.m., okay? But actually, you can't because the room is full, but okay. You can watch the recording, okay? So, what is ACI? In a nutshell, ACI is three things. First and foremost, and this is something that this message was a little bit lost at the beginning, it's a network, okay? It's an application-centric infrastructure. It's a network. It's a better network based on the use of VXLAN as a data plane to forward packet leaf to leaf, but it's a network, okay, that you can use to connect your endpoints. Even if you don't know anything about your application, you can still use ACI because it's a network, okay? It's a better network, but it's more than just a network. It's a network with a database on top, okay? So everything that happens in ACI, every configuration, every policy, every log, every statistics, it's an object and has an information that we put in this database, which is in the EPIC, which is the controller cluster on top of ACI. And the big differentiation of ACI as a fabric solution compared to other solutions is exactly that, right? ACI, the EPIC is a REST API. It's an open REST API that provides you insight into that database. And when you have insight into a database with all the information, you can do a bunch of things, right? You can monitor, you can do data operation stuff, you can grab all the information you want, right? Everything that happens in ACI is in that database. The third thing ACI is a secure network, right? It's identity-based networking. Every time you connect something in ACI, you classify that endpoint as part of what we call EPG, endpoint group, and by definition, endpoints in different endpoint groups cannot talk to each other, right? The famous whitelist deployment model. So it's a secure network, identity-based network, which provides advantages in terms of security, because as I said, we don't allow communication unless you really want to. And on the other point, enables also automation, because if I know when and where an endpoint connects, I can also provision the configuration when and where that endpoint is connected. If I move an endpoint from leaf 1 to leaf 200, I'm going to provision the networking construct, the infrastructure construct that endpoint needs to have connectivity into the network. So it's security and enabling of automation. Okay? That's what ACI is. Now, the slide already changed because it was already bored of me explaining it. So ACI anywhere. When we talk about ACI anywhere, some people just think about the last part, which is the integration with the cloud, with the public cloud. In reality, ACI anywhere is the whole story. Okay? We started ACI in 2013, end of 2013, 2014, and ACI looked like that, right? It was what we called a single pod. Typical leaf spine topology, all the leaf fully meshed to all the spines, and that was the new way to deploying data center fabrics. Okay? The reason why we do leaf spine, at this point everybody knows, right? More east-west, more resiliency, et cetera, et cetera. Okay? But that's what ACI was. Now, right after its injection on the market, customers started thinking, well, nobody has a single data center, right? If I have more than one data center, if I have more than one ACI network, how can I interconnect them? How can I leverage this ACI technology? How can I leverage the simplicity that having an epic controller cluster on top gives me across different ACI network, across different data centers? And so in ACI 2.0 version, we deliver multipod. And so multipod was delivered, and we'll talk a little bit more about that, for these two reasons, right? To scale up a fabric. If I want to build a fabric with 300 leaf, does it make sense to build it as a single pod, or does it make sense to build it as a multipod? It makes sense to build it as a multipod, and I'll clarify why in a couple of minutes. Okay? So multipod is a way to scale up a fabric without losing the simplicity from an operational perspective, given by the fact that I still have a single epic controller cluster that manages all the network devices across the different pods. Right? It's still a functional fabric. And the beauty of multipod is the fact that it's simpler, is simple to operate, and is functionally rich, because every functionality that works in ACI pretty much works out of the box in multipod as well, because it's a single epic domain. Okay? However, depending on the use case, multipod could not be the right fit for you, right? And think about a disaster recovery use case, which is a typical example. Why? Because having a single epic controller cluster is good, because it allows me to make changes and have the changes propagated across all the pods. And so that means a layer 2, to extend layer 2 my data center, I don't need to do OTV anymore. I don't need to do mapping of VLANs to OTV, VLAN to VPLS. I just define my bridge domain. And then I attach my endpoints. End of story, right? That is good, but at the same time, if I make a change, if I make a mistake, that mistake propagates across all the pods. It's a single change domain, okay? That's the reason why, for a disaster recovery story, even if there are customers that are in production with multi-pod and they do disaster recovery, it may not be the greatest idea, because if I make a change to my production data center and I affect also my disaster recovery site, that's not a great disaster recovery story to tell, okay? And this is the reason why we went ahead with this ACI Anywhere journey, and we deliver multi-site, which is the topic for this presentation. And multi-site gives you what multipod wasn't giving you, which is complete, not only network full domain isolation between the data center that you already were getting with multipod, but also change domain, right? Each site, each fabric, it's an independent epic domain. So now, yes, I can go and make a change, push that change to fabric A, to site A, without pushing any change, any configuration change to fabric B, right? Production changes. If I make a mistake or there is a problem, I can do recover my application in the disaster recovery site, which remains unchanged. And allows me also to run if I want, different ACI releases between one site and the other, right? Which may be also important because maybe I want to upgrade my production data center, but I don't want to touch the disaster recovery site, okay? The journey then continues. So these multi-pod and multi-site are really the two architectures to interconnect data centers. And based on what I just said, you understand, we are not planning on discontinuing one versus the other. They are there to stay, and as I will clarify, they are there to stay together, right? Really marrying multi-pod and multi-site, depending on the use case, is the right strategy to follow. What we then started doing was, okay, thinking, what if I need to extend connectivity to part of the network where I don't need to build an entire fabric or an entire pod? What technology, how do I extend the ACI connectivity to this edge part of the network, right? Typical example, 5G service provider scenarios where you want to deploy services close to the user, or migration scenarios where I may have a legacy data center running 7K, 5K, 2K architecture, and now I want to build a new ACI fabric and I need to migrate endpoint between the legacy data center and the new ACI fabric. How do I interconnect the two? How do I allow that endpoint migration? And this is where we deliver something called the remote physical leaf. Okay? The remote physical leaf, the idea is instead of deploying in a remote location an entire spine leaf topology that could be run as a pod or as a site, depending if you do multi-pod or multi-site, I just deploy a pair or remote leaf. And that remote leaf, the pair or remote leaf, physical remote leaf, is managed by the central epic, like if they were local leaf, right? And this applies from the point of view of the provisioning of the remote leaf, the zero-touch provisioning, right? You know that when you want to add a leaf to an ACI fabric, what do? You unpack the leaf, you cable it up, and you power it up. That's it, right? It will join the fabric, it will get all the configuration. The remote leaf is the same, right? You unpack the remote leaf, you connect them to the upstream layer 3 network, and then you let the magic happen, right? The remote leaf will register with the epic and will get all the configuration it needs. So remote physical leaf is the easiest way to extend the policy and the connectivity, layer 2 and layer 3, depending on my requirement, to these edge parts of the network. The other part of the remote leaf is what we call the remote virtual leaf, or it was launched as a virtual pod. The idea of the virtual pod, think about, is similar to the remote physical leaf. The idea is to be able to connect remote compute workloads to the main ACI fabric. But with the virtual pod, with the virtual leaf, I don't even need to deploy a single piece of ACI hardware, which is not very good for me, right? Because they need to pay my salary, but you will pay some licenses anyway to install the virtual switch. But point is, if I only have in my remote location, if I have a bare metal cloud, if I have a legacy data center where I have virtual machine, and I want to connect the virtual machine to my new ACI fabric, I could just deploy the virtual leaf, which basically run on the hypervisor where that virtual machine are running, and that virtual leaf will basically be able to encapsulate the traffic back to the main site using the same technology, VXLAN, using the same control plane, which is MPBGP EVPN. Okay? So the remote leaf are a way to extend the connectivity and the policy of ACI to all the part of the network. The last step, so these four parts of the journey have already been delivered. The last step, which will be delivered in a first implementation at the end of the month of February in the 4.1 release, is the integration with the cloud. Okay? And this is what it was launched this morning. In the first phase, we integrate with AWS. In the second phase, later this year, we will integrate with Azure. And then probably in 2020, we'll go to the Google Cloud as well. And the idea is, that's the architecture called multi-cloud. The idea of multi-cloud is that I'm going to run my on-prem private data center, private ACI fabric, and my public cloud VPC as if they were two sides of a multi-site environment, right? So really, I still have, as we will see, a multi-site orchestrator on top, and the sites now are on-prem data center or public cloud resources, right? But from a data plane, control plane, and capacity of extending policy end-to-end, I basically have the same experience, user experience, that I have with multi-site, right? That's why the session today is also important, because once you understand how multi-site work, you basically know how multi-cloud will work as well. And so the idea behind all this, again, is to ensure that you can position, you can deploy the workloads, your workloads, wherever you need, based on your business requirement, and not based on connectivity restriction, right? ACI Anywhere remove the problem for you of extending connectivity and policy and allow you to deploy the workloads on remote location, on colo location, on public cloud, on bare metal cloud, wherever you need to do so, based on your business, okay? Does this make sense? Hopefully, okay? Now, let's go more into, back to the topic of interconnecting data center, right? And here, we start introducing, and again, this is important to understand the difference between multi-pod and multi-site. We introduce the concept of availability zone and regions, okay? Now, depending who do you talk to, depending on the market, depending on the vendor, the term availability zone and region have a different meaning, right? In AWS, for example, you know, right? The data centers that AWS build are availability zone that are all interconnected as part of a region, and then there are different regions, right? And depending what you deploy on AWS, a VPC can only be part of a specific region, for example. A subnet can only be part of an availability zone, right? And so you have this construct that ensures that when you deploy something in the cloud, you have a certainty that if something happens to an availability zone, you don't have a problem in a different availability zone, okay? When we go to ACI, how do we map this concept of availability zone and region to the architecture multi-pod and multi-site that we discussed? Well, the typical requirement that infrastructure people have is that I want to be able to support my application team. I want them to be able to deploy application in my data center, but I want to be sure that whatever I do, whatever happens to when I do a change in one part of the data center, I can ensure that I have a separate availability zone where the application runs across so that I will never create an outage for my application. So the creation of two independent availability zone is what everybody, at least two, it's what everybody should do from an infrastructure perspective. And what an availability zone is, when we talk about ACI, an availability zone is an epic domain. Okay? It's an epic domain, so it's a fabric. It's a fabric because a fabric represents a single change domain, right? From an availability perspective, is the set of devices that are affected as a whole every time I make a specific configuration change. So I build, in this example, a pair of availability zone, two epic domain. This epic domain could be single pod or could be multi-pod. Doesn't matter, right? A single pod fabric or a multi-pod fabric is still a fabric, is still an epic domain, is still an availability zone. I deploy my application across availability zone, and to allow connectivity between this availability zone, I put multi-site in place, right? So multi-site is the glue that interconnects different availability zone, different epic domains, using a multi-site orchestrator. And so the region is essentially the set of sites, the sets of availability zone, the sets of fabrics that are managed by the same instance of the multi-site orchestrator, okay? And now you see how these two architectures start coming together, right? And we actually didn't support the combination of multi-pod and multi-site from the very beginning. It came in the release 3.2, that was in April 2018, and many customers were waiting for that because the typical use case is, especially in US, you have a pair of data center in a metro area that are called the twin data center, which are run and managed in a truly active fashion, right? So I want to stretch ESXi cluster across the data center, I want to do DRS, I want to do vSphere HA, fault tolerance, and then, more remotely located, I have a disaster recovery site, right? And then, in that example, multi-pod is the perfect architecture for the metro data center because it allows, in a simple way, to manage this active data center environment, and multi-site is what allows you then to connect to the disaster recovery site in case something bad happens to the metro data center, okay? So the combination of the two architectures is really what the majority of customers are working with is planning to do. That's it for the introduction. Hopefully this start making sense. So you start, continue to think in terms of availability zone and region, and basically availability zone, epic domain, region the set of availability zones that are managed by the same multi-site orchestrator. So basically, they are part of the same multi-site architecture. Now, quickly, because I don't want to steal the thunder of John, that tomorrow is going to talk for this for 90 minutes, but a quick review of ACI multipod. What multipod is, as I said, it's an availability zone because it's an epic domain, but it's a better way to build an availability zone. You could build an availability zone by building a single pod, but if you have reason because you want to scale more in terms of leaf, number of leaf, or because you want to separate that large fabric into smaller pieces, that's where multipod comes to the rescue, right? And the reason is, if you build a single pod with 200 leaf or 300 leaf, right, you basically have a single network fault domain. You have a single instance of all the control protocol that run in ACI, like ISIS, COOP, and PBGP, that run end-to-end, okay? We multipod, we separate that. So we chop that large fabric into smaller parts. Each of these parts is a pod, which is a leaf spine topology, and that pod runs its own instance of these fabric control plane protocols. If I have an issue in ISIS in pod 1, that issue will never propagate to pod 2, 3, or 4. Okay? So I'm able to scale better, build a more resilient fabric, and separate the network fault domain without changing the fact that it remains simple to operate because it's a single epic domain is a single change domain. Okay? And in functional terms, multipod uses VXLAN as the data plane to interconnect endpoints that belongs to different pods, right? This is the famous east-west communication. Every time an endpoint in one pod needs to communicate to an endpoint in the other pod, it's an east-west communication. We use VXLAN pod to pod. The use of VXLAN has two big advantages. One is it makes this network interconnecting the different pods very simple, right? It's just a routed domain that needs the VXLAN traffic to go across. Now, if you're familiar with multipod, you know that, well, it needs to do a little bit more. It needs also to support multicast today because we need to be able to send also layer 2 flooded traffic, right? Like layer 2 multicast, layer 2 broadcast across. And we use multicast in the transport network to ensure that each pod, when I need to send a multi-destination traffic to 5 other pods, I only send one frame into the transport network, and I have the transport network doing the replication for me. So it's a more efficient way of doing it, but which comes with the price of having to support multicast inside here. We are working in removing this limitation, right? Or better, give you also the option to have multipod working in ingress replication mode, which will make this network providing only unicast routing support, but it will require a new hardware on the spine. So this will come later this calendar year, and that's the reason why we haven't done it until now, right? It's not because we want to torture you with multicast, or we want to make you multicast expert, but mostly because the currently shipping hardware for the spine does not allow us, we multipod, to support the ingress replication, okay? If you don't believe me, come and find me at the end, I will explain you exactly why. But point is, VXLAN is important because it makes this network simple, and VXLAN allows you to carry also metadata. And the metadata that I carry across is network information, so I know which bridge domain or which VRF the traffic was originated from or is sent to. And more importantly, since ACI is also an identity-based network, I carry the identity of the endpoint with me. I carry the EPG identifier, which is called the class ID, so that when the packet gets to the destination, I can apply a policy that says, oh, this comes from EPG1, it's trying to talk to EPG2. Do I allow that? Do I have a redirect policy? What do I do with this? I can apply an intelligent policy decision because the policy comes with the traffic, right? And that's how we extend the policy domain across the different pods. Now, in order to know where the endpoints are, we use MPBGP EVPN, which is a control plane that runs pod to pod. It doesn't run in the network, in the transport network. It runs spine to spine and allows to exchange reachability information, okay? So now the COOP database in the spine has knowledge. It learns locally from COOP and from the remote pod from MPBGP VPN. It knows where all the endpoints connected to the fabric are located, in which pod are located, the local pod or the remote pods, okay? That's what multipod is. The other consideration of multipod is two considerations. One is being a fabric, a single fabric, you are bounded to a maximum number of leaf that you can support. Okay? And we have a maximum of 400 leaf, which is not a limit that says if you connect the switch 401, the data center will crash, right? That's not going to happen. It's what we validated, and it's a limit that we put because we think that 400 leaf in the same availability zone, it's a significant number of devices, right? We don't want you to put all the eggs in the same basket, essentially. Okay? So one concept is the scale. The scale of multi-pod fabric is the scale of a single fabric. Two, the latency between the pod is limited because I want to be able to stretch my epic cluster across for resiliency purposes, and I want an epic here to be able to manage leaf or spine that are in the remote pods, right? So we are bound to a maximum 50 millisecond latency between the pods, okay? These are two considerations that are important because we will see they change with multi-site. Now, I said multi-pod, it's a fabric, it's an availability zone, it's a single tenant, it's a single change domain, which is true. However, you also need to keep in mind that ACI, being a better network and supporting multi-tenancy, allow you to define different tenants, right? And so the change domain in ACI is really not the fabric itself, but it's the tenant inside the fabric. If I have a tenant dev and if I have a tenant prod, if I can have two different tenant administrators, the one connecting to the tenant with the credential for dev will never be able to make any change that impact prod, and vice versa, right? So it's true there is a single availability zone, it's true there is a single epic domain, but the changes, right, can be scoped for each tenant independently, okay? What is common to everybody is the infrastructure configuration, the tenant infra configuration, right? Because that's where all my overlay tenant run on top, okay? So what are the most common use cases for multipod? The most common use cases are either inside the physical data center when I want to scale up the fabric, right, in a more resilient way. So instead of building, as I said, a 200 leaf topology, single pod leaf spine, I chop it in smaller pods, right? So that each pod is a different network fault domain. It's a more secure, a more safe, a resilient way from an infrastructure perspective of building a fabric. Second use case is when I want to actually interconnect data center that I really run and manage as a single logical entity. The classic active-active data center. I have an ESXi cluster stretched between my data center. I want to be able to move workloads dynamically between them. I don't want to care if the web tier workload runs in data center 1 or data center 2, because for me, it's a single availability zone. It's a single highly available environment, okay? So truly active-active data center is where multipod shines. That's it about multipod. For the rest, you go to see my friend John tomorrow. Any question on multipod? I told you were shy, okay? Are they asking any question? They're shy also on writing, man, okay. Okay, so maybe the question will start more when we talk about multi-site. So what about multi-site? Overview. So first of all, let me say, if you want to see multi-site in action, if you want to see the multi-site orchestrator also in action, you can go, there is a lab ACI 1142, where you can go actually and play with it, right? So you will see how the multi-site orchestrator look, and they will actually give you some use cases about how do I migrate legacy network to multi-site, okay? So what multi-site is, from an architectural perspective, it looks very similar to multipod, isn't it? So I have this different ACI network interconnected with an external network, which we call the intersite network instead of the interpod network, for obvious reason. But the striking difference from the slide that was showing multipod is the fact that each of these ACI network is now an independent epic domain. It's an independent availability zone. And the union of that, all the sites that are under the control of the same multi-site architecture, of the same multi-site orchestrator, build essentially a region. Okay? It's a region of availability zones, interconnected between them. From a functional perspective, we still use VXLAN as data plane. We still use MPBGP VPN for control plane to the exchange of the reachability information, with some difference compared to multipod, and I will clarify them when I talk more specifically about the data plane and the control plane. But the third functional component that needs to be introduced with multi-site is the multi-site orchestrator, right? Is the brain that manages the policies, the configuration, if you want, that are pushed to the different sites. It's what really allows to give you the capability of controlling the change domain, or controlling the changes that you make so that it can be scoped to a specific site. I can deploy my policy for application 1 on the multi-site orchestrator and say, deploy application 1 in site 1, but not in site 2, and vice versa, right? And when I want to do a disaster recovery, I can push that policy to bring my application from site 1 to site 2, for example, okay? So the multi-site orchestrator is the policy manager where you define the tenant policies. It's not what you use to manage to do the bring up of the fabric. That you still do on the epic, right? It's not replacing the epic. It's complementing the epic by providing this policy manager capability. And we will see the multi-site orchestrator also gives you the capability, day 2 operation capability. We'll give you a single pane of glass where you can go and see, okay, are my sites connected correctly? Is the VXLAN data plane healthy? Is the EVPN control plane healthy? Do I have issues that prevent an endpoint in site 1 to talk to an endpoint in site 2, right? And why cannot talk? Is it policy? Is it connectivity? What is the problem, right? The idea, the vision, and I say vision because not all this functionality are already there, but we're getting there, is to put a lot of day 2 operation emphasis on the multi-site orchestrator, okay? Now, when to do multi-site? Use case number 1, is I want to build a massive data center, right? It's a physical data center. We have some service provider that come and they say, okay, I need to build a data center with 2,000 leaf. What can ACI do for me? Well, I cannot say, yes, build a single epic domain with 2,000 leaf. It would make no sense, right, to build an availability zone with 2,000 leaf, okay? So in that case, you can combine multipod and multi-site inside a physical data center and build, for example, 5 multipod fabric with 400 leaf each to get to the 2,000 leaf scale that you have to, right? It's more a very large scale use case for service provider. Most of the enterprises, they wouldn't need to look at multi-site for that, right? For the physical data center location, multipod is usually more than enough to scale up the fabric, okay? The other use case is data center interconnect. We will see multi-site is one of the best, I would say, data center interconnect solution on the market, and is what make actually the term DCI sort of obsolete, right? When we were talking DCI, we were talking a plethora of technologies, OTV, VPLS, Ethernet MPLS. We used to have a tutorial where we spoke for 8 hours, right? Myself, Victor Moreno, Patrice Bellagamba, we were talking for 8 hours about how can you interconnect your data center, how do you extend layer 2. All this discussion is now gone, it's all simplified, right? If I want to do DCI, all I need is to interconnect my different sites, make them part of the multi-site architecture, and then I will have layer 2, layer 3, policy extension between them, okay? And that's really where the goal, where multi-site shine. As I said, would you deploy multi-site for a classic active-active data center deployment? Maybe, right? I will show you why is probably not a good idea. Would you deploy multi-site to connect a classic active-active data center to a disaster recovery site? Absolutely, right? Because that's really one of the use cases that shines for multi-site. Not the only one, but one probably the most common. Let me give you bad news right away, and maybe most of you know. With multi-site, there is an hardware dependency on the spine, right? We cannot support multi-site if the spine is a first-generation spine, like the 9336 PQ, for example, okay? Why that is the case? The reason is, I'll clarify in the next slide, right? But not just because we want to sell you the new hardware, right? But because there is actually a couple of functionalities that that spine needs to do to play in a multi-site architecture that the first generation spine cannot do. Now, the two types of spine can coexist inside of a fabric, right? You see here, I want to do multi-site from this pod, from this fabric. I add a couple of spines, but the spine connected to the external network, to the intersite network, can only be the second generation one, Okay? Cannot be the first generation. The first generation is only used for the intra-fabric communication. Okay? But they can coexist in the same fabric if you want. Okay? So why do we need this second generation spine? Well, the reason number one is because multi-site needs to basically put together two different namespaces. What do I mean with that? So I told you that every time there is a communication, when I explained multi-pod, I said every time an endpoint in pod 1 wants to talk to an endpoint in pod 2, we create a VXLAN tunnel. And in that tunnel, we carry network information and we carry policy information. The exact same thing happens in multi-site. Okay? But the main difference is that while in multi-pod, I have a single epic domain. So when I define an EPG and a bridge domain, the epic will assign to that bridge domain a VNI identifier, because we use VXLAN, and will assign to the EPG a class ID, an EPG identifier, which is consistent across all the pods, because they are under the control of the same epic. We multi-site, the EPG that I create, if I have an EPG web that I create on my multi-site orchestrator and I deploy in site 1 and in site 2, the resources that the epic 1 and the epic 2 assign to the same EPG web is different, right? Probably different, because there are two different brains that assign values to this same object independently. We do not federate these two epics, right? They act independently. So we need multi-site to enable the east-west communication. We need to basically normalize this namespace. And what does it mean? I'll show you with an example, because it's the easiest thing to do. Imagine that what I want to achieve is I want my green EPG to communicate with my yellow EPG. And the green endpoint is sitting in site 1, the yellow is sitting in site 2. Okay? When the VXLAN traffic leaves the leaf where the endpoint is connected, the leaf is going to add into the packet the metadata, which is the identifier of the VRF or of the bridge domain, depending if it's an intra-subnet or inter-subnet communication, bridging versus routing. I have network information that identifies the network segment where the source endpoint is connected, and I have a class ID which identifies the EPG. This is the green guy, class ID 49153. That packet goes across the network. When it gets, let me go back, sorry. When it gets to the spine inside 2, the spine needs to send the packet into the local site. But before doing that, he needs basically to know, okay, wait a moment. This is traffic that comes from the EPG green. The EPG green, how is it, what resources does he have locally assigned inside of site 2? They are likely not the same values that the epic 1 assigned in site 1. So what the spine needs to do is basically a translation between the VNID value that means green in site 1 with the VNID value that means green in site 2, and between the class EPG, the EPG identifier that means green in site 1, with what actually means green in site 2, right? And that translation needs to be done, obviously, line rate. We don't want to pay a performance price because of that, right? So we want to give you the flexibility of having completely independent namespace domain where the VNID doesn't need to be the same, the EPG identifier doesn't need to be the same, but we need someone that does a translation, right? And the spine, the second generation spine, is capable of doing that line rate. That's why, reason number one why we need the second generation spine. And that basically, that means that when the packet goes inside site 2, I have the new VNID, I have the new class ID, which means green in site 2, and when I get to the leaf can then apply the policy. Green talks to yellow. This is the contract that I specified on the multi-site orchestrator. I'm going to do what my intent was defined, right? I drop, I allow, I redirect to a firewall, I do whatever I need to do, okay? Is this point clear of the namespace normalization? Because that's the critical point of multi-site, right? That's why multi-site took a little bit longer also to be deployed. We needed a new hardware. We needed more work. Multi-site does more work for you under the hood. You don't need to care about that. Everything will happen under the hood. But you need to know that there is this namespace normalization requirement across sites. Okay? Question. The question is there. OK, I will repeat it. Go ahead. The question is, OK, so if I go back, how are these translation table populated, right? What populate the information there. Are the spine exchanging this information via the control plane VPN? No, it's basically the multi-site orchestrator that when push the policies to both epic, it gets back the information about from epic 1, domain 1, what is the identifier that means green in site 1, and communicate that information to the epic in site 2 so that it can program the translation table, and vice versa. So it's the multi-site orchestrator which has the key role of getting the information, what are the values that are being locally instantiated to each of these objects, and communicate to the other epic domains so that the translation table can be populated. Which is a very important, and I thank you for the question, it's a very important point because it means that if I want green to talk to yellow, using the VXLAN data plane, I need to define this policy on the multi-site orchestrator. I cannot go independently on epic and create green here and yellow here, because if I do that, nobody will tell the epic how to populate the translation table, right? So every time there is a need for east-west communication, that policy needs to be defined on the multi-site orchestrator, okay? Second important point, I need to have a contract every time green wants to talk to yellow, at least up to release 402 that just shipped, we needed to have a contract between these two APG specified on the multi-site orchestrator. Because it's only the establishment of the contract that basically allows to populate this information and also exchange endpoint reachability information via EVP and control plane. If I don't specify a contract, the two APG will never be able to talk to each other. Now, this has been changed in the latest release, 402, where we introduce support for preferred group, also with multi-site, right? Preferred group we already supported on Epic on a single fabric. Preferred group means I'm going to group together a set of EPG which I want to communicate freely with each other, right? So if they're part of the same preferred group, which is enabled at the VRF level, the endpoint, the EPG, the endpoint part of this EPG can communicate without having to apply a contract between these different EPGs. Obviously, every time I want to talk with something which is outside the preferred group, I still need a contract, okay? This was not supported, this configuration was not supported on the multi-site orchestrator. It is now supported, right? And why it was not supported? Because you understand what needs to happen under the hood. If I define these three EPG and I put it in a preferred group, that means that under the hood, the multi-site orchestrator needs to tell the epics to program the translation table across all the sites to allow this communication to happen, right? That's the piece of code that was added in release 402, okay? So now you can basically remove the policy aspect if you want for a set of EPG out of the equation also with multi-site. When this is useful, usually in migration scenario where you have a legacy network that you want to connect to ACI, and in the legacy network, you didn't have policies between the different VLANs, and you want to start like that, right? You map an EPG to a VLAN, and you would like just to use ACI for connectivity initially, instead that policy. Mostly because you don't even have no idea, probably, what policy you need to apply between the different VLANs, okay? So you start with no policy, and then you start tidying up the security when the time comes, okay? So preferred group now supported with multi-site. Let me look at the time, good. Now, from a network perspective, from a communication perspective, I told you, multi-site is the best DCI solution. It means they need to give you the capability of communicating, extending communication between the site. That could be layer 2 or could be layer 3, depending on the use case. So there are really three different communication patterns, right, that you can enable with multi-site. First one is layer 3 communication. Like my example, I gave you an EPG green and EPG yellow. If they're part of two different bridge domains, I need to route across the site, okay? And this is for customers that, and there are many, that were born in the past by, extending layer 2, spanning 3 loop between the data center, and they're like, I don't want to hear about extending layer 2 between my sites. Go away, right? In that case, there is still value in using multi-site, not only from a day 2 operation perspective, but also to enable the routing communication between sites using the VXLAN data plane. So logically, you treat that communication as an east-west communication, which means if I have a perimeter firewall in front of my L3 out, that communication happens behind the firewall, right? Because it's a site-to-site, it's a data center to data center traffic pattern, right? I shouldn't go through my perimeter firewall for that communication. So using multi-site for routing makes a lot of sense. Normally, if I want to do that, it means that when I go and define my bridge domain, in this example, the red bridge domain and the green bridge domain, one inside one, one inside two, I define the bridge domain as not layer 2 stretch, right? I remove the check, L2 stretch, which means that bridge domain is only confined to site 1. I don't extend the layer 2 domain across, okay? Now, usually when the question I get right after describing this is, well, what's wrong in doing this? What's wrong in having my red and green talking to each other? If all I need is routing, why can't I just do routing through the L3 outs? There is nothing wrong. You can do that if you want, right? I would not recommend it for 2 reasons, or 3 or 4 reasons, actually. One is, as I said, if here you have a firewall, it means that your east-to-west communication, red to green, will have to cross the perimeter firewall in front of both data centers, right? Which may not be desirable because you want to really treat that communication as an intra-data center environment communication, okay? Reason number 2, I don't have a multi-site orchestrator here where I go and define my policy. Red, I want red to talk to green with these specific security rules. What I need to do here, I need to go to Epic Domain 1 and say, okay, red can talk to the external world. And on the other side, I need to say traffic that comes in L3 out here will be classified as red, and then it can talk to the endpoint green, to the EPG green. So I need to apply 2 contracts in 2 different places, Epic 1 and Epic 2, to allow red to talk to green, right? And this is because green is seen as an external destination from the point of view of site 1, and red is seen as an external destination from the point of view of site 2. Is it terrible? It's not terrible, but you have 2 touching points, right? Can you deploy an orchestrator on top that automate that for you? Absolutely. You can rebuild the multi-site orchestrator if you want, right? But we give it for you with a little price, but okay. I mean, we have to pay the engineer that did the multi-site orchestrator, right? So that's the idea, right? With the multi-site orchestrator, you have a single place, and you really define your policy. You don't worry about L3 outs. You're like, I want red to talk to green with this contract, period, okay? Reason number 3 is if I have multiple VRF here and I want to enable routing between VRFs here and VRF there and keeping the logical isolation end-to-end, I need the network in the middle here to be multi-VRF capable, right? So I need an MPLS VPN backbone. I need to map the L3 out with the VRF to the right L3 VPN service, blah, blah, blah. That's not needed when you use the VXLAN data plane site to site because the VRF information is carried in the VXLAN header, right? So for me, it's just VXLAN traffic. The backbone is a single routed domain with native multi-site communication. And the last reason is, even if you say, I will never do layer 2 between the sites, will always come the day where you need to have actually layer 2 extension between the sites. And if you have a deployment like this in the totally independent fabric, it means you need to go back and deploy OTV or VPLS or PBB, whatever it is, a layer 2 VPN solution to extend a layer 2 domain between the sites. Instead, with multi-site, you can enable a layer 2 extension. You can enable the configuration of the same subnet in site 1 and site 2 by simply defining the bridge domain as an L2 stretch object and by pushing that configuration to Epic 1 and Epic 2, okay? It's as simple as that. It's a click, it's a check and click. That's it. The bridge domain now will be extended, which means the same subnet will exist in site 1 and site 2, but when I extend the bridge domain, I have 2 flavors of that, the good and the bad, if you want. The good one is the one where I say I want to stretch the bridge domain, but I don't want to allow the BAM traffic across. So I want to be sure that I can move workloads from site 1 to site 2 without changing their IP address. I can do that doing vMotion. I can do that using Site Recovery Manager. I'm talking in VMware terms because everybody knows about these tools. I can move an IP from site 1 and site 2, but if I have a broadcast storm that hits the site 1 in the bridge domain, the broadcast storm will never propagate to the other site. And if you think about disaster recovery, an IP mobility scenario with disaster recovery, if a broadcast storm in your production data center can propagate to the disaster recovery site, my friends, you don't have a disaster recovery solution, okay? So you want to be able to provide IP mobility without stretching the bad stuff across the sites. And you can do that with this setting here. Okay? From release 3.2, we support also the live migration without the need to extend the BAM. And this is the only solution on the market that can do that, right? Not even VXLAN multi-site can do that. Don't tell Lucas that I said that, but that's the reality, right? And the reason why we can do that is because with multi-site, with ACI multi-site, we have the EVPN control plane between sites that basically informs all the sites where the endpoints are located, right? So I don't need to flood because I don't know where my endpoint is connected. And we built in 3.2 all the functionality required to handle also the silent host scenario. If a host is moved and he goes silent, he doesn't send any packet, and is not discovered in the new location, ACI will force that endpoint to reply to an ARP so that it's going to be discovered and I can enable communication to it. Okay? So this is the right way of doing layer 2 extension between the sites. However, with multi-site, we support also what I jokingly call the bad way, which basically means it's a more traditional way of extending layer 2, where I extend also the BAM traffic. Why would I need to do that? Is because I may have an old application cluster, and the nodes of that application, I want to stretch them across sites, and I want to deploy, they need to communicate with a layer 2 protocol, right? Layer 2 multicast, layer 2 broadcast. Should you do that with multi-site? If you ask me, it's not a great idea, okay? Because doing that, you basically join the two independent availability zones. You make them become a single network fault domain, right? A broadcast storm propagate across. You can do that, support this with multipod, makes sense, because then with the multipod, then you can have a separate site being your disaster recovery site, and you go back to this use case. But if you want, if we didn't do that, I should have spent 1 hour convincing you, right, that was a bad idea. So the best thing is to say, yes, you can do it, right? Absolutely. It's only a check. Basically, you say, this bridge domain is stretched, and I allow the BAM, and you're done. Now you can do a layer 2 multicast, layer 2 broadcast across the site. Should you do that? In my opinion, no. You be the judge for you, right? But the good thing is that these 3 different behaviors can be enabled on a per bridge domain level, right? So I can have bridge domain that only exists in a site. So I'm in scenario 1. I can have bridge domain that I extend because I want to do site recovery manager. I want to do a true IP mobility use case, and that's the scenario 2. And I may have few bridge domain where I need to support legacy application, and I take a little bit of risk with that by I extend the layer 2 domain in a more classic fashion, right, including the BAM. So my expectation is that 90% of the bridge domain should be in the category 1 and 2, and only the exception should be in 3. Even better if you have 0 in 3, if you ask me, okay? So these all configurable on the multi-site orchestrator. So this is what multi-site gives you. It gives you the capability of communication, layer 2, extending layer 2, extending layer 3, in a very controlled way, which is something that multipod does not give you. With multipod, when you define a bridge domain, the bridge domain exists everywhere, right? Because it's a single availability zone, okay? Now, in terms of scale, a few more things. When you look at the scalability guide, you will always find 2 columns from multi-site, right? There is the column 1, where you find a so-called stretch object. Stretch object means an object that exists in multiple sites at the same time. If you extend a bridge domain across 2 sites, that becomes a stretch object. Stretch means the same bridge domain exists in the 2 sites. Doesn't mean BAM or non-BAM, means I create that bridge domain in both sides. I create a VRF in both sides, right? That becomes the stretch object. And then there are the site local object, which are the objects that only exist in one given site, right? And so you need to look at this table. You need to look on the fact that release after release, we have increased the scalability value. But if you see in this slide any number that concern you for your potential new multi-site deployment, come and see me, and let's see what you can do. Because these numbers are mostly related to what has been validated, right? They are not hardware-driven numbers. They're really soft validation specific numbers, okay? And you see, from the release 4.0, we support now 12 sites, 12 fabric, right? Where each of these fabric could even be a multipod fabric, right? So you see how many ACI network now we can start interconnecting, right? 2 more points before going a little bit more in the weeds of the packet walk. With multi-site, and I will clarify, I will harp on this a little bit more later. We remove the need to use multicast in the network, in the intersite network, when you want to extend BAM traffic, right? So only for the third use case that I told you you shouldn't do, if you want to do, and you need to extend BAM, we don't need the multicast to run in the intersite network, right? Because we do ingress replication. So the spine in the source site where that BAM frame is generated will know to which other sites that bridge domain has been extended, and we create unicast VXLAN packet sent to all the remote sites that have the same bridge domain, so that all the endpoints can get the frame like if they were sitting on the same traditional VLAN, okay? The fact that we remove the requirement for multicast means that we can now support also this, right? The direct interconnection of spine back to back without having to deploy a layer 3 device in the middle, which is something that we cannot do today with multipod for the reason that I mentioned, because we need the multicast, we have the multicast requirement. As soon as we remove the multicast requirement from multipod, then you will be able to do this also with multipod, which, if you ask me, is going to be way more common and more useful than doing this in multi-site, right? I don't see many customers that will interconnect two sites back to back, right? Mostly because multi-site has been designed to interconnect fabric that can be deployed across the globe, right, on global scale. So it's very rare that you will interconnect with multi-site two fabric that are connected directly. But if you have that requirement, you can do that today, from the beginning, actually. Actually, no, from 3.2, not from the beginning, okay? The other important point, which is actually way more relevant for multi-site, is if your security department mandates you that every packet that leaves the data center needs to be encrypted, right? What you could do is, well, you can deploy, like you always did, encryptor outside of the data center, connected to the fabric that encrypts the communication. From the release 3.2, we started supporting, or actually 4.0, I take it back, we started supporting what I call like CloudSec. What CloudSec is the capability in a multi-site deployment for the spine in site 1 to encrypt traffic destined to site 2, right? So it's an equivalent of MACsec, but while MACsec is done at the physical link layer, and so it can only be applied device to device, and if you have here lots of devices, you will need to do MACsec across all of them. CloudSec is an overlay encryption, right? Encryption starts on the spine and terminates on the spine there, which doesn't mean you need to encrypt inside the data center. If you want, you can. You can do MACsec between leaf and spine, but even if you don't do encryption here, the spine on the fly will encrypt the traffic when it needs to leave the data center to go to the remote site, right? And for this, we need, obviously, not only the second generation spine, but also the FX, right? Not EX line card, FX line card, or the new baby spine that are the 9364C or the 9332C, right? Because we need this capability now, not only of doing the translation, but also the encryption on the fly. And this is all hardware-based because we want no performance implication in doing so, okay? So this is way more relevant, in my opinion, as a requirement than the back-to-back connectivity, okay? Now, the multi-site orchestrator, which is the brain of the multi-site architecture, what is it? What is it today, or what will always be? It's a cluster of 3 nodes, right? Today, actually from the release of multi-site in 3.0 until today, each of the nodes of this cluster needs to be a virtual machine, okay? So you go on cisco.com, you look at the multi-site code, you will find an OVA. You download that OVA, you can run it on an ESXi host, and that becomes one of the 3 nodes of that cluster. And then you cluster 3 nodes together, they're all active, and they basically run like Epic, right, with the concept of quorum, majority, minority. So if I lose one, I have 2, the cluster is still alive. If I lose 2, the cluster go in read-only minority state, okay? So usual database redundancy model. The important thing is that from a communication pattern perspective, the virtual machine, the nodes of the cluster need to communicate with each other because they replicate the information. You connect to one of them, you do your configuration, he writes in his own database and then replicate the same information to the other 2 nodes, right? Because the database needs to be consistent end to end. Question? Thank you for the question. I forgot to say that. So the question is there any plan to deploy a physical form factor and appliance for the multi-site orchestrator? There are plans. It should come, I believe, John, was it release 4.2 that we do the physical form factor for the MSO? I think is the release 4.2 in the second half of the year, Q3 calendar year. So it will be a UCSC. At that point, you will have 3 UCSC being your EPIC, 3 UCSC being your multi-site orchestrator, okay? But in terms of communication, and there is a question? I don't see anything yet. Yes. Can you give the mic? Because, yeah.
Yeah, I was curious, the spine translation table, which devices maintain it, or which devices store it?
The question is, which device maintains the spine the translation?
The spine translation table.
Yes.
Which device stores it? Is it the spines, the APICs, or the MSOs?
The MSO communicate the information to the EPIC, which go and program that on the spine itself, right? So then you can connect to the spine and do a show command, and you will see the entry over there. Okay?
Thanks.
Yeah. So in terms of communication, the nodes of the multi-site orchestrator, they need to communicate with each other, as I said, because they need to replicate the information. And so there is a maximum latency that we can support, which is 150 milliseconds, which is not short, but is not also across the globe, right? So the idea is you want to keep the cluster somehow in the same continent, at least, right? If you are a global enterprise with data center in US, in Europe, and in Asia, you want to deploy the cluster in the same continent, in Europe, for example, or in US. But from there, you can then manage EPIC domain fabric that can be up to 1 second RTT of latency, maximum, right? Which basically means across the globe, okay? So it's really a global architecture that allows you to interconnect and manage data center deployed across the globe. You just need to keep in mind this consideration of the latency between the different nodes. Question? Is it possible to run only one instance for lab purposes? Of course, even in production if you want. No, meaning, and it's a joke but not a joke, in the sense that if you lose the multi-site orchestrator, you basically lose the capability of creating new inter-site policies, but your EPIC we are still up and running, all the statistics will still gather at each fabric level, right? And you can, even if that fails, you can then reconstruct all the policies by bringing up a brand new multi-site orchestrator node and importing a snapshot from a database, for example. Right? The snapshot of the database, and you will have all the configuration, right? It's stateless per se. Question?
Any solution for the golf feature? Multi-site?
Any solution for golf with multi-site? We'll talk about that when we talk about L3L connectivity. Give me 10 minutes, maybe 20. The other important point is that not only latency, but the communication between the multi-site orchestrator and the EPIC needs to happen, must happen, with the out-of-band address of the EPIC. This EPIC here is trying to escape the site. I don't know why, but I made a mistake in the slide. So I need the multi-site orchestrator to be able to talk to the out-of-band address of the EPIC. What that means is that I don't really care, and I don't want, actually, to connect the multi-site orchestrator to the fabric. I can connect the multi-site orchestrator wherever I want in my backbone, as long as I have connectivity to the out-of-band address of the EPIC, right? And so the recommendation is, obviously, if they are virtual machine, don't put the 3 of them on the same ESXi host for resiliency purposes, and also put them in part of the network where it's less likely that you will have a failure that will isolate the entire cluster from the rest of the network, right? So you have lots of freedom on where to deploy these 3 nodes. You will have even more freedom once you have the physical form factor, because then it will be a server that you can really connect on any switch of your infrastructure, okay? If the fact that it's a VM doesn't mean any way that you need to run it on an ESXi host that is connected to the fabric, right? You can deploy with a physical server just an ESXi, put an ESXi hypervisor on top, and run the VM there like if it was a physical appliance, right? You can simulate the behavior of a physical appliance already today. You still need to deploy that ESXi hypervisor, which we will remove that requirement in the second half of this year, okay? Now, as I said at the beginning, the multi-site orchestrator is not replacing EPIC, okay? There are some functions that the EPIC will always continue to own, right? Functions like the fabric bring up, the zero-touch provisioning for the leaf and the spine, the definition of infrastructure policies, the definition of the domains, right, VMN domains. A VMN domain is done by peering the EPIC with the vCenter or with the SCVMM or with the OpenStack controller, right? These operations, they're still going to be done at the EPIC side, at the EPIC level. What you do on the multi-site orchestrator are all the configuration, all the policies that refer to a tenant, right? So EPG, bridge domain, VRF, to enable inter-site connectivity, or even if you want to deploy an application, web app DB in a single site, you define that object on the multi-site orchestrator, and then you push that configuration to the site where you want to deploy that application, okay? All the tenant policy, you do it on the multi-site orchestrator. All the infrastructure stuff, you continue to do it on the EPIC, okay? And when we talk about defining tenant policies, we basically created two policy constructs. One is called the schema, and one is called the template. So the schema is just a container of templates, right? The place where you go and define VRF, bridge domain, EPG, contract, it's really the template. So inside the schema, I can have multiple templates. Today is 5. What you associate to a tenant is the template, not the schema, right? So the schema is just a container. I could have in a schema 5 templates that are for 5 different tenants, for example, right? Is the template that is associated to the tenant, not the schema. More importantly, is the template that then gets associated to one or more sites, right? If I define my green wants to talk to yellow here, and I know the green and yellow only exist in site 1, and I want to keep that communication confined to site 1, I would take my template, associate it to site 1, and that policy will always be pushed to site 1. If I want to enable an inter-site communication green to yellow, because I know that the green endpoint, the green subnet exists in site 1, the yellow subnet exists in site 2, I create this policy on the template and associate the template to both sides. And at that point, I will push that configuration to both EPIC domain to allow that east-to-west communication to happen, right? When I do this, that triggers also the communication with the EPIC to then program the translation entries in the spines. But the important point is that you need to keep in mind is that because of this, the template becomes the atomic unit of change, right? When I make a change to this template, if the template is associated to 2 sites, I will push the change to both sides, right? So from that point of view, it's a behavior like multi-pod, where when I was making a change on EPIC, the change was propagated to all the pods under the control of the same EPIC. This is the same when I make a change in a template, which is associated to multiple sites, which essentially means if you're after a disaster recovery use case, it may not be the best idea to have a single template associated to the production site and the disaster recovery site, right? We are working on an improvement to give you the capability of defining a single template, but give you the freedom of say, okay, I make a change to that template, now let's push it to the production site, see the effect, and if I'm okay, then I push the same template to the disaster recovery site. That's not how the multi-site orchestrator works today. That's where how we want to work in the second part of the year, okay? Is that clear? So the template is important, and this was a surprise, I'll be honest with you, it was a surprise also for me when I started playing with the alpha code of 3.0, because I defined a template, I associated it to the 2 fabrics, and then I was like, okay, I want to make a change and push it only to fabric 1, and I couldn't find how to do it, right? And the reason was because the template is the atomic unit of change, right? If I want to have independent change domain, I need to create different template, one associated to one site, one to the other site. The multi-site orchestrator, on top of doing the definition of the policy, as I said, we want to make the single pane of glass where you also go to see what's going on in your multi-site architecture, right? And what's going on, the first functionality that we deliver for that in 3.2 is what we call the consistency checker, right? When I create a policy, green and yellow needs to talk with this contract, that creation of the policy, pushing the policy to the site, will need to basically program, render the configuration on the nodes, the leaf and spine on that site. Like, for example, also the translation table. The consistency checker go and verify if, based on your intent, based on the policy that you define on the multi-site orchestrator, it goes and verifies if the policy has been properly rendered, so if the spine and the leaf have been properly configured in both sides, right? And if it gives you yes, it means that you don't have a problem. It's a sort of assurance functionality that you get out of the box with the multi-site orchestrator. The plan is to add more and more day-to operation function, right? So that, as I said, I want to know that this endpoint in site 1 cannot talk to the endpoint in site 2. Is it because I have the wrong policy? Is it because the VXLAN data plane is broken? Is it because I don't have the endpoint information, right? All this information will be provided for you on the multi-site orchestrator itself. You don't need to go and fetch the same information on different epic clusters, okay? Other point, and I'm not the right guy to tell you this because I suck at programmability, but the same programmability that, as I told you at the beginning, Epic is a programmable fabric, right? Because I expose a REST API that I can use to basically consume, create policy, gather information. The same thing can be done with the multi-site orchestrator. The multi-site orchestrator offers a REST API, public REST API, and I can have orchestrator on top of that, like UCSD, or even Ansible, which many customers start using Ansible to interact with the Epic. They will be, in the next release coming at the end of the month, there will be Ansible module that allows you essentially to interact directly to the multi-site orchestrator, with the multi-site orchestrator, right? To do what? To do creation of sites, to do creation of templates, to associate templates to site, to push the policies, blah, 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 okay? So that's the GUI. It's one way of using the multi-site orchestrator. Obviously, the same programmability benefit that you get with ACI, you need to get it also with the multi-site orchestrator. Right? So if you like Ansible, stay tuned, because in the next release, you will have that capability. Now, inter-site connectivity, how am I doing? I'm doing okay. Inter-site connectivity between sites. What does the network need to do? Well, I told you, it's a single routed domain, it's a simple network. So what it needs to do, it needs to be able to route, right? If your inter-site network cannot route, you have bigger fishes to fry that worry about multi-site, right? You need to figure out what's going on. But if an IP packet can be carried from spine 1 to spine 2 across the sites, that's all you need for that inter-site network. Almost, right? What you also need, two more things. You need the increased MTU support, and this is because VXLAN encapsulate all the east-west communication, which means, I will show you, there is a control plane and a data plane implication for that. You also need another thing, which is, by implementation, when you connect a spine to the external device in the inter-site network, all the traffic that the spine generates is going to be tagged with VLAN 4. So we create a sub-interface, okay? That uses VLAN 4 to send the traffic to the external router. The same thing happens inside the fabric, right? If you go and look, the interfaces connecting the spine to the leaf, they are not layer 3 physical interfaces, they are layer 3 sub-interfaces, right? It just, you never cared, right? And because it's something that is happening automatically inside the fabric. Here, you need to care because it essentially means that the device up here connected to the spine needs to be able to support sub-interfaces with the same VLAN 4 tag across different physical sub-interfaces, okay? So that's the requirement that this device needs to have. On the facing the spine, on this side, I don't care, okay? Now, back to the MTU 1 second. When we talk about MTU for communication between sites, there are two aspects. Control plane MTU, which essentially is, no, what happened? No, that's the data plane MTU. Sorry, data plane MTU, which essentially means when I have an endpoint that wants to send traffic to an endpoint in the other site, the packet will be encapsulated, and it will be sent, sorry, let me go back. It will be sent across the network with an extra 50-byte header. So how much MTU support do I need here? Well, it depends what these endpoints generate, what packet generate. If the endpoints generate a default 1500 byte packet maximum, here all I need is 1500 plus 50. If I have endpoints connected to my fabric that are configured for sending jumbo frames, 9200 byte, then here I need 9200 plus 50, right? So we used to have at the beginning of multipod, we mandated 9150 byte MTU support in the interpod network. That requirement is now gone, right? From a data plane perspective, it really depends. The endpoints connected to your fabric, what is the maximum MTU that they generate? Then you need to increase that by 50. The second aspect is the control plane. The spine needs to establish an EVPN peering, and they need to use the EVPN peering to exchange reachability information. So by default, the control plane MTU, so all the control plane traffic generated by an ACI node, being a leaf or being a spine, comes with a 9,000 byte maximum MTU, which essentially means if I don't do anything and I leave the default behavior, I will need to support 9,000 plus 50 byte of MTU to allow the spine to communicate with each other. Okay? If in that external network I have jumbo frame support, so be it. I can leave the default. But if, for example, I have maximum 200 byte MTU support, then I need to go in this global setting and change the control plane MTU, which is generated by the spine. Okay? So that the maximum EVPN update is going to be 2,000 byte. This control plane is not VXLAN encapsulated, right? So if 2,000 byte is what I have across the network, 2,000 byte is what I put there. But you need to keep that in mind, because if you don't do that, you will see an interesting thing, which is the peering between the spine will go up because you use a small packet to establish the BGP adjacency. But when you start trying to exchange reachability information, that packet will probably be dropped in the external network. So you will have zero prefix learn through that EVPN peering, right? I've seen that day in and day out with multipod and with multi-site as well, okay? Now, control and data plane. Let me pause 1 second so I can drink. Any question at this point? You're awfully quiet. Other, I'm very clear. No, I see. Okay. Yeah. Okay.
Thank you. It requires to have a layer 2 extension if you have multi-site orchestrated stretch between 2 data centers, right?
No, because each multi-site orchestrator node can have an IP address in a different subnet, and the epics also can have an IP address in different subnet if you want, right? So you just need layer 3 communication between the IP that you give to each MSO node and the epic that I'm trying to connect to.
Not between the nodes of the MSO.
The MSO nodes can be layer 3. There is no layer 2 requirement.
Thank you so much.
No problem. Other question? Yes.
Does the ISN network have to be a dedicated point-to-point link, or can we use an existing, for example, MPLS cloud between 2 data center sites?
The ISN, as I told you, multi-site is a global architecture. Like you could have a data center in Singapore, one in New York, one in Paris, right? So then ISN network is whatever infrastructure you have between these data centers. So could be an MPLS core, could be the internet, could be whatever you want. Okay, as long as I have IP connectivity and as long as I can allow that MTU traffic to go across. Now, when I say that we have a requirement to increase the MTU, the spine, when it generates traffic, does not set the don't fragment bit, right? So if you have inside the ISN network devices that will fragment and reassemble the traffic before sending to the destination spine, it will be totally fine. There will be probably a performance implication, right? But that's something that is taken care by the intersite network. What the spine cannot do is to fragment or to reassemble, okay? Just to be clear. Better is, if it's a network you manage, increase the MTU so that from a performance perspective, you don't have any problem. Okay, control and data, question over here. Yeah. Try again, sorry.
Yeah. So the question is, which interface are the nodes using when they are in different sites? So you have 2 in one site and 1 in the other. So they are communicating over the interface connecting to the fabric, or they are using the out-of-band?
You're talking about the multi-site orchestrator?
Yeah.
Usually, as I said, the multi-site orchestrator, you don't even want to connect it to the fabric, right? So you will have a single interface that is connected to the network where the multi-site orchestrator connects to, and you just need to have connectivity to the out-of-band address of the epic, right? Could be your out-of-band network, could be whatever network that allows you to talk to the out-of-band address of the epic. That's
so
it.
Then
they will have a single interface, essentially, right?
So you need to stretch your out-of-band connectivity from sites.
You need to stretch that. You need to, the same way you are able to talk to the epic to connect from your browser to the epic in site 1 and the epic in site 2, right? You will need the multi-site orchestrator to be able to talk to the out-of-band in site 1 and out-of-band in site 2. Yeah.
Thank you.
Sure. One more, and then I continue. We don't finish.
You mentioned the MTU needs to be incremented by 50 bytes. What if you do encryption?
If you have an IPsec tunnel created in the intersite network, then you need more, right?
Yeah, but if the
the encryption for the cloud sec. Yeah. Yes, there is a. Thank you for the question. There is an additional, I think, is 42 byte for that.
Okay.
Yes, absolutely. Yes. So do 100, and you are safe also in case you want to enable cloud sec, right? Because really enabling cloud sec is going to be a check on the multi-site orchestrator. You say cloud sec site 1, cloud sec site 2, and you're done. The traffic starts being encrypted, right? Which is pretty powerful. So control plane, one important thing that we want also to achieve from an architectural perspective is that we wanted the site to be able to communicate with each other without making any assumption about the TEP pool that you originally picked when you brought up the fabrics, right? You would not believe, we did a research with TAC, you will not believe the TEP pools the customer have picked for their internal ACI fabric. Some people have multicast ranges that they use for the TEP pool. Some people have public ranges that belongs to other companies. I've seen everything and more, right? So the assumption with multi-site is that for all the communication between sites, we will never create a tunnel to the TEP pool that exists, that has been defined in the fabric, which means essentially I could also have the same TEP pool, 10.0.0/8. I use it in site 1, I use it in site 2. I don't care. So what do we use for that inter-site communication? We basically we do what we call the day 0 infra configuration on the multi-site orchestrator, and we assign, point number 1, to each spine we assign a specific IP address, which we call the EVPN router ID, which is then used by the spine to communicate, to create an EVPN, a BGP peering, essentially, with the spine in the remote sites, right? And this happens automatically. You just need to say BGP on, obviously. You don't need to do anything else, right? But that BGP session will be established using this EVPN router ID loopback, if you want. And then, for the data plane traffic, you have two types of traffic. Unicast traffic, that could be layer 2, if it's bridging, switching, or layer 3, if it's routing. We use what we call the overlay unicast step, which is one single IP address that is an Anycast VTEP, if you want, that is owned by all the spine in that site, right? So every time I talk to something that exists in site 2, I see everything coming from site 2 reachable through that single overlay unicast step address that identifies site 2. That's all I know, okay? If I stand layer 2 with BAM, and I need to do ingress replication, we use as a destination a different unicast IP address, which is the overlay OMTEP, the overlay multicast step. Okay? So if it's BAM traffic and I need to send it to site 2, instead of encapsulating to the overlay unicast step address of site 2, I encapsulate to the overlay multicast step address. And this is useful because the spine that receives the packet, based on the address, knows immediately if it's a BAM frame or if it's a unicast communication. Okay? But these are basically 1, 2, 3, 4, 5, 6, if you see here, 6 addresses that I need to add per site, if I have 4 spine, otherwise it will be 4, when I want to enable every inter-site communication. And the range, the network from where I pick that addresses, it's completely in your control, right? So what you need to ensure is that you pick addresses that can be routed across the backbone, interconnecting the sites. Could be public if you go across a public network, could be private, but not overlapping with any other network that you use in your backbone, okay? So once I assign that addresses, the peering comes up. If I enable the peering, it comes up. And then I can start using that peering to exchange endpoint reachability information. However, before the peering can come up, I need to ensure that after I assign the EVPN router ID to the spine in site 1, the site 2 spine know how to get to that router ID information. And what we use for that, we use an OSPF peering, like with multipod, like with Golf, between the spine and the external network. Okay? That OSPF peering is used to exchange all the 6 addresses that I showed you before. In reality, we also send out, we do not filter the TEP pool that has been defined inside the fabric. So that's also announced to the first top layer 3 device. Why we do that, it will be more clear when I talk about multi-site and multi-pod integration. But the point is, I don't need, what I need to do, what I recommend that you do on the first device on the intersite network, you filter that tap pool so that you don't inject that tap pool into the backbone, right? Because it may very also happen that this tap pool overlaps with some other part of your network, your backbone. You don't want to send that into the backbone because you don't need it, right? You don't need to send that tap pool information. All you need to send are the host route, the 6 host route that you define in site 1, you want to send them to site 2, and vice versa, from site 2 to site 1, okay? So filter out the tap pool, please, to keep your backbone clean. And this information, these 6 host routes that are received through SPF, then are redistributed inside ISIS. So if I go on a leaf, the leaf knows how to reach something connected in the remote site because it knows how to reach the overlay unicast step and the overlay multicast step address, okay? Now, as I said, once I exchange this EVPN router ID, I can establish my control plane. And when the control plane is up and running, I can start exchanging reachability information. Now, with multi-pod, every time an endpoint is discovered in a pod, since it's a single fabric, that the information about that endpoint, is MAC, is IPv4 address, or is IPv6 address, needs to be communicated to all the other pods, right? Because the database in the spines of all the pods need to be in sync because it's a single fabric. I need to know where everything is connected. It's my availability zone. With multi-site, I want to send information about endpoints to the different site only if I need to do so, right? If I never want to talk, if this bridge domain that I define in my site 1 is never needs to communicate with anything else in the other sites, why do I want to send information for endpoints of this bridge domain to the other site? It's pointless, and it will impact the overall scalability of the endpoints that you can support across the different sites, right? So with the example, very quickly, EP1 connect, COOP, communicate the information to the local spine. The local spine put the information in the COOP database. The same happens when EP2 connects in site 2. At this point, EP1 is only known in site 1, EP2 is only known in site 2. When I go on the multi-site orchestrator and I create a policy that says green needs to talk to yellow, and I push it to the sites, at that point, the EVPN control plane kicks in, and the information is going to be exchanged, right? And now I will know, if I go in the COOP database of site 1, I will know the EP2 is connected to site 2, so it's reachable via the overlay unicast step address, which identifies site 2. If I go to the COOP database of site 2, I see the opposite information for EP1. Okay? And this table will be populated with all the endpoint information to allow the yellow to green communication to happen. We only send, at this point, we only send host route information. We do not send subnet information across the site. Okay? So even if a bridge domain is not stretched, and this is an easy optimization to implement, but we haven't done yet, even if a bridge domain is only existing in site 1, all I would need to send to site 2 would be only the subnet, right? But instead, we send the host route for all the endpoints. But from a scale perspective, it's not a concern, right? It will be just an optimization to reduce the entries in the remote spine routing table. Now, the other point is, oh, I thought there was a question, sorry. From a data plane perspective, once my EVPN exchange information, how do these endpoints communicate with each other? And this is that by PowerPoint, showing the packet walk, right? I know. But it makes you understand also how ACI works a little bit better. So I will try to do fairly fast. So EP1 generates a packet. The destination is EP2. You know that with ACI, we do not install nothing from a routing information perspective on the leaf until we know that a local endpoint needs to communicate to that remote endpoint, right? So remote endpoint information is only installed on a leaf based on received data plane traffic. So if this is the first time that EP1 wants to talk to EP2, I probably don't know where EP2 is, but if I have a contract created on the multi-site orchestrator that says green can talk to yellow, we will install the subnet of yellow on the leaf where green is connected to say, when you don't know what to do, send the packet to the spine. Okay? The packet will be sent to the local spine. The spine will look in this COOP database and it will be like, okay, I know where EP2 is because I learned it from my control plane exchange with the site 2 spine. So it will encapsulate the packet toward the overlay unicast step, which identifies site 2. If you see, an interesting thing happens, right? When the packet was going from the leaf to the local spine, the source address in the external header, the VXLAN header, was the tap of the local leaf where the endpoint green was connected. That source IP address is changed by this spine on the fly so that every packet that goes in the inter-site network is always being seen as a communication between the IP address that identifies site 1 with the IP address that identifies site 2. Okay? So I don't need to know, and that's why we don't need to send the tap pool across, because I don't care about the tap pool, the tap addresses of the leaf. I want only to see all the communication between sites as a single flow between that source IP and that destination IP, which makes simpler also to troubleshoot that communication pattern across the network. Okay? Now you may wonder, well, but that means if I have equal cost path, I'm going to use always the same link, and I keep maybe 3 links unutilized. And the answer is no, because when we do the VXLAN encapsulation, which is a UDP frame, we basically, based on the internal header of the original traffic, we create entropy in the header of the external packet by changing the source UDP port, right, based on the hashing of the original packet. So different flows from endpoint that belong to site 1 and site 2 will create different source port. And so you can then load balance based on layer 3, layer 4 information in the external network and use all the available equal cost path. Okay? So this is just a simplification, but it does not give you any problem in using redundant path at the same time, right, statistically. So the packet gets to the destination spine. The destination spine does the lookup. It sees that EP2 is connected to the local leaf. Send the packet down to the local leaf. Up to now, this is just connectivity, because I've not been able to apply any policy. Why? Because at this point, I don't know who yellow is, right? So in site 1, I cannot apply this policy that I said I want to apply, because I don't know the EPG of yellow, okay? So for the first pass, the policy can only be applied on the receiving leaf, okay? When the packet gets to the leaf, it carries the information after doing the translation. I know that packet comes from green. I know I want to talk to yellow. Yellow is locally connected, so I know it's EPG ID, and I apply the policy, the contract that I define, right? Which again could be allow, deny, redirect to firewall, whatever it is, okay? And when I receive this packet on the data plane, I learn also the information on the leaf that EP1 is connected to site 1. So the EP1 MAC or IP is going to be associated to the overlay unica step of site 1, okay? When the EP2 responds, I have the information at this point in the table. I know where EP1 is. I know which class ID, which EPG EP1 belongs to. So I apply the policy right there immediately. If the policy say forward the traffic, I send directly to the destination spine, to the destination site. One of the 4 spines will get the packet because they all own the same overlay unica step address, right? So equal cost. I go to one of them. The one that receives the packet will basically send it to the local leaf. When the local leaf receives it, it will learn the location of EP2 on the data plane. I will not apply the policy again because I set a bit in the VXLAN header that says I already apply policy in my source site, so the packet will be directly forwarded to green, right? And at this point, the table in these 2 leaves are fully populated to basically start establishing directly communication between site 1 to site 2, site 2 to site 1. And the tunnel is always established between the leaf and the destination spine, with the point I made already that the local spine will change on the fly the source IP address to replace the original leaf VTEP address with the overlay unica step that identifies the local site, okay? So that all the communication are always between these 2 IP addresses only. That's it from a data plane, right? And this works for layer 2. This works for layer 3. Now, what if I stretch BAM? Even if I shouldn't, well, if EP1 sends a BAM frame, the BAM frame inside the fabric is going to be replicated using multicast, right? We have different multicast tree for availability and for performance. All the spine will get the packet. One of the spine is elected for that specific bridge domain as the designated forwarder. So only the designated forwarder will basically replicate that packet to the destination sites where that bridge domain has been extended. So it will create multiple copies, depending on how many sites I have, putting as a destination address in the external header the overlay multicast step address that I defined for that site on the multi-site orchestrator, right? That overlay multicast step address is owned by all the spines. So one of the 4 spines will get the packet, and then we'll basically send it inside the fabric associated to the multicast group, right? Using multicast, again, intra-fabric. And so the endpoint will get the packet like that. Okay? That's how BAM traffic is extended in case you want to extend it using ingress replication. But again, think twice before enabling this, right? Be very careful. Question at this point. You're already dead. Only 90 minutes, I already killed you. Come on, man. I asked for a 2-hour session to finish you properly. Okay. There is a question here. Yes, sir. Correct. The question is, I said that to exchange the 6/32 addresses, right? The EVPN router ID, the overlay tap addresses between sites, we need to use OSPF between the spine and the first layer 3 device of the intersite network. What about if inside the intersite network, if it's an extended network? You can do whatever you want, but you need to redistribute what you learn through SPF into whatever routing protocol you have in the ISN and vice versa, right? You need to ensure, which is actually a good thing because if you use only OSPF there, the filtering is very easy, right? I said the tap pool you don't want to send in the backbone. Well, you just need to avoid redistributing into the backbone protocol, right? And you just redistribute the 6/32 addresses that you need to communicate to the remote site. So you need to ensure that if you do SPF end-to-end, you don't need to do anything, just filter in the tap pool. If you use BGP inside the ISN, you need to redistribute to SPF to BGP and vice versa, okay? All right, connecting to the external layer 3 domain. If you build a data center and you don't connect it to the external layer 3 network, there is something. Oh, there's a question. Sorry. I don't see anything down there. So, yeah.
Sorry. What happens if the spine goes down?
What happens, sorry?
If the spine goes down.
What happens if the spine goes down? The answer is nothing, right? And this is because, as I said, all the traffic going between spines between sites is destined to an address which exists on all the spine that I have. So if one of the spine goes down, the OSPF information for that will be reflected. So I will have a routing convergence that says, okay, to get to that IP address, this path is not good anymore because the link went down probably, and one of the remaining spine will keep receiving the flow that was received by the failed spine, right? So it's like bringing down a node when you have an equal cost path. You basically reshuffle the traffic on a different available link, right, toward a different available spine.
Thanks.
Sure. Okay, as I was saying, if you build a data center, you don't connect it to the external network, why did you even bother building the data center, right? So you need to connect your fabric or your multi-fabric environment to the external network. And now, Mr. John Weston is Mr. L3 out himself, right? He's the master of this stuff, but when you talk about connecting ACI to the external world, you create L3 outs connection. And there are really two different flavors. One is, has always been supported, the support of L3 out on the border leaf, which basically means I create a sort of VRF light peering between, for each VRF that I want to extend out, I create a peering using a routing protocol between the border leaf and the external device. If I want to extend 10 VRF out, I create 10 VRF light peering, okay? The other approach is what we call like golf. Okay? What golf allows you to do, instead of doing VRF light, and for every VRF, create a new peering, specifying the border leaf, specifying the interfaces, with golf, I do a day 0 configuration where I peer my spine with the external router, the golf router. They need to be ASR 9K or Nexus 7K or ASR 1K. I establish an EVPN peering with them, and I use that between spine and the golf router, and I use that EVPN control plane to exchange reachability information for all the VRF that I want to extend out, right? The advantage is why golf was created. Was created because for large scale L3 out deployment, right? If I have 1,000 VRF in my data center and I want to extend 1,000 VRF out into my MPLS VPN backbone, I may not want to create 1,000 VRF light peering, between the border leaf and the external network. And in fact, we do not support that level of scale with the traditional L3 out. I think the limit today is 800, if I'm not mistaken. So we are getting close, even with the border leaf, but it used to be 400, and even less before. Okay? So really, Golf was a technology that was targeted for large service providers that had to extend connectivity outside of the fabric for lots of VRFs. But why many enterprises started looking at Golf? For one, and solely one functionality that Golf L3 out was giving until today, that the border leaf L3 out were not giving, which was the capability of advertising host route information out of the fabric. Right? With the border leaf L3 out, I could only send the subnet associated to the bridge domain. With Golf, I could send the subnet plus the specific host route for the endpoints discovered inside the fabric. And this is very handy when I have a multi-pod or a multi-site deployment, because I may want to influence traffic coming in so that it comes right to the right data center where the endpoint is located. Okay? This unicity of Golf L3 out has now disappeared, and we support, from the release 4.0, host route advertisement directly on the border leaf. And I will show you how you can use that. Right? So that removes, in my opinion, the need to look at Golf for majority of the enterprises. Because really, I work with many of them. They had a need for extending 4 VRF, maybe. They were very static in nature, so configure once and then let them stay. And they were doing Golf just because they wanted to send out the host route. Right? The message is, Golf is not dead. Golf is still there. But if you were thinking of Golf just because of that, now the good news is that you can do that natively on the border leaf themselves. And I will cover that in a second. Okay? Other than that, you can use Golf L3 out with multi-site the same way that you do it with a single site. Right? You will have, most likely, you will have different pair of Golf routers. That's to address the question of the gentleman. You will have different pair of Golf routers, one for one site, one for the other site, if the sites are very far apart. But it's just the definition of an L3 out. There's nothing special about that. Okay? Now, no matter if you do border leaf L3 out or Golf L3 out, there is one specific consideration when it comes to communication to the external world from a multi-site environment. And the consideration is, what we support up to today is only use of L3 out connection that are local to the site where the source and point of the traffic is connected, right? So what we cannot do with multi-site, but we can do it with multi-pod, is having an endpoint in site 2 communicating to something that is connected to an L3 out connection that exists in site 1. Right? That's something that some people call shared L3 out. I call this inter-site L3 out connectivity. Is it a big deal for communication to the WAN? Some customers ask me, well, I want to be sure that if I have a connection to the WAN here and I have a problem, I keep talking to the WAN through the remote site. Right? That doesn't work today. When this has become a bigger deal, in my opinion, is when you connect endpoints like mainframes to the fabric, right? And you need a client inside 2 to talk to a mainframe inside 1. In that case, the mainframe talks OSPF, so you need to connect the mainframe to an L3 out. Today, we'll not be able to have a client to mainframe communication across sites. We are fixing this, right? This will come in the release 4.2, 4.1, which is Q3, beginning of Q3, calendar year 19, so right after the summer, okay? So this will work, but today it does not. So you need to keep that in mind when you have something connected in L3 out mode to a given site. What is some implication for that? Imagine that I have multi-site and I'm stretching my web bridge domain across sites. Now, what could happen is, if I don't do anything, I will announce the subnet of this bridge domain out of the L3 out of site 1 and site 2. And imagine I have a firewall. This should have showed up later, but I spoiled the surprise. Imagine I have a firewall, a perimeter firewall in site 1, a perimeter firewall in site 2. So the traffic could happen that it comes in site 1, even if the destination is an IP address for that extended bridge domain that exists in site 2. Multi-site will do its job for inbound traffic. It will be able to take the packet and send it to the site where the destination is connected, right? Because we extend that connectivity. But the response from that endpoint will have to use the local L3 out, which means my SYN went through the firewall 1, my SYNAC goes through the firewall 2. These are independent firewall they are not syncing connection state, and basically I create an asymmetric traffic path and I drop the traffic. How do I solve this problem? The easiest way is to leverage what I said, the functionality that we deliver in release 4.0 for the border leaf, which is the capability of announcing host route information, right? We can enable that at the bridge domain level. So when you define this bridge domain, you say, go announce host route here and do announce host route that. As a note, we do not support this setting here yet on the multi-site orchestrator. So that means that from the multi-site orchestrator, you would create the bridge domain, and you will say it's stretched across the two sites, but then today you need to go at the epic level and enable that flag that you see there to enable the host route information. Obviously, we are going to bring that on the multi-site orchestrator. It was just, don't get me started, why it's not there from the beginning. It should have been there from the beginning, right? But it's not, okay? So, but you can do that setting at the local epic level. Okay, if you want to enable host route. And if I enable host route, then I can make my ingress and egress traffic symmetric, right? And I avoid the SYN-SYNAC asymmetric path problem that I showed you before. Another way to solve the same problem is to connect the firewall in a different way and to steer the traffic to the firewall in a different way. And to understand that, we need to talk about services integration, right? Multi-site and services integration. Integration models are pretty much the same that we have with multipod, right? I can do active standby across site. I can do active-active across site. I can, but it doesn't work, right? So you shouldn't. If you want to do a cluster, if you want to stretch a cluster, an ESXi cluster, a service firewall cluster across data center, multipod is your friend, right? Because you do that, the availability model of that is basically extending the cluster in the same availability zone. It makes no sense to do something like this with multi-site. I create a separate network, and now I join them together by stretching a cluster across, okay? Makes little sense. That's the reason why this works only in a very specific configuration. This is not supported at all. The second is not supported at all. What makes sense with multi-site is to have each site having its own pair of active standby firewall, for example, or active-active firewall defined in site 1 and a separate active-active cluster in site 2. So the idea is these sites, this fabric are independent network, and so the services that run there are also independent. However, to avoid the problem I showed you before, we need multi-site to give help, right? To give you help, we need to leverage the additional intelligence that an ACI fabric and a multi-fabric environment has to avoid the creation of asymmetric path. And how does it work? And we support this from release 3.2. You go on the multi-site orchestrator, and for north-south, you create a policy that says externally PG green wants to talk to an internally PG web. And the contract is not just a permit or deny. It basically says, the contract says redirect the traffic to the firewall. So every time the external world wants to talk to web, I don't allow the communication happen until I go through a firewall. And then in each site, I connect an independent firewall, okay? I push that configuration from the multi-site orchestrator. What then will happen is if the traffic comes in from the external network into site 1, the first thing that happens, by default, the VRF is configured with policy control enforcement ingress, which essentially means for north-south communication, we never apply the policy on the border leaf. The policy is always applied on the compute leaf. So traffic comes in. The first thing I do is pure networking. The traffic is sent to the leaf where the destination web endpoint is connected. At that point, the web endpoint is there. So I could send in the traffic, but I would violate my intent, right? Where I said, no, green cannot talk directly to orange. Green can talk to orange only through a firewall. So what happened is the PBR policy, this policy, kicks in on the destination leaf and redirect the traffic to the local firewall. Again, the local firewall could be an active standby cluster, an active-active cluster, whatever you want, right? This is running in unmanaged mode. It's the use of service graph in unmanaged mode. There is no device packager, right? It's the use of ACI just for steering the traffic to the firewall. If the packet was coming in site 1 and the destination was in site 2, same story. Networking done first. I go to the destination leaf. On the destination leaf, I apply the PBR policy. The PBR policy redirects the traffic to the local firewall and then to the endpoint, right? So if I use host route, I will just remove this suboptimal hairpinning of traffic, but functionally, I don't have a problem even with the host route to support this. Why? Because when this is incoming traffic, when the response comes back, from this endpoint, the PBR policy is applied on the same leaf. So I go through the firewall in site 1. From the endpoint in site 2, I apply the PBR policy here, and I go through the firewall in site 2. So from an L3 out perspective, if I go back one slide, for communication with the .11, I came in L3 out 1, and I'm going to go back through L3 out 2. But from the point of view of the firewall that I use for the two legs of the communication, I'm using the same firewall, which is the firewall inside 2, right? So I make symmetric the two flows, inbound and outbound, across the same service node, okay? And this is what multi-site gives for you. The same thing, exactly the same thing happens also for east-to-west communication, right? Not only north-south, also east-west. The only difference is that we need to pick one side, the provider or the consumer side, where the PBR policy needs to be applied to avoid, depending where the points are connected, to avoid creating the asymmetric path. But it works exactly the same way, right? And I'll leave it this for your reference, okay? So the bottom line is you can integrate services in a perimeter firewall, for example, in a very network-oriented way and use host route to make symmetric the traffic, or you can actually create use a service graph and PBR for the same purpose, okay? Very quickly, multi-site and VMN domain integration. If you integrate the EPIC with vCenter or with SCVMM, by definition with multi-site, it's very likely that you will have independent vCenter in the different site, but the same consideration will be the same if I had a single vCenter. Since I have independent EPIC domain, this will always end up with the creation of separate VMN domain, right? What does it mean? It means that I'm going to push separate distributed switches, right, VDS or whatever it is, to the host in site 1 and to the host in site 2. So I can still do live emotion, for example, with vSphere 6.0 and above, but I can do live emotion only manually initiated. I cannot do DRS initiated emotion. I cannot do vSphere HA. I cannot do vSphere fault tolerance. I can use SRM to do the migration, right? So I can do IP mobility, but I cannot use the typical technology that I use in a traditional active-active data center, right? If I need that, if that's my requirement, the two data centers need to be connected with a single VMN domain, and so again, multipod is your friend for that, okay? Multipod and multi-site integration. Two use cases. We have many customers that already deploy multipod. Again, this could be the metro data center, a scale-out fabric. I now want to connect to my disaster recovery site using multi-site, and so I end up with multipod plus multi-site, right? So a fabric could be a single pod fabric or a multi-pod fabric. I don't really care. The other use case is I start with multi-site from two single pod fabric, and then for some reason I need to scale up one of the two fabric, adding another pod to it, right? And so I end up essentially with the same topology, right? Two use cases that end up with the same combination, multi-pod plus multi-site. In terms of connectivity, couple of scenarios. One where the same network can be used for the inter-pod connectivity and inter-site connectivity, right? So I may have this device here is at the same time the IPN first stop router that allows multi-pod traffic to go across, and is also the traffic that allows the inter-site traffic to go across. So it's a single network that I use for IPN and ISN. Another use case could be, which is to me more common, I have two separate infrastructure for IPN and for ISN, because for IPN, I normally have DWDM, dark fiber, I have direct point-to-point link between my pods, okay? Because I'm in the metro area, I'm in the same campus. This other data center is out of the blast radius if it is a disaster recovery site, so I go through a WAN backbone, for example. In this case, we can support that, but the key point is that I can only use one single infra L3 out defined on the EPIC, so that a single set of link needs to be used for the traffic, both for multi-pod and for multi-site. What we don't support is having separate link, one to connect to an IPN network, one to connect to an inter-site network. Is it a big deal? To me, it's not, because if I need more bandwidth, I can add more links here, right? But from a configuration perspective, the multi-site orchestrator owns the infra L3 out that is created on the epic, right, on the spines, and so I can only have one infra L3 out with one set of links. That's why we do not support this, right? So keep that in mind. Scenario 1, scenario 2 is the one that you can do. From a BGP control plane perspective, we said that the spine across sites needs to pair with each other. If I have a multi-pod fabric, I may have a lot of spine. Think about 10 pods, 4 spines each, I may have 40 spines. Do I want all the 40 spines to pair with the remote spines? The answer is no. So we basically have the concept of BGP speaker and BGP forwarder. On the multi-site orchestrator, for each site, that could be single pod or multi-pod, you go and define which one are the speaker. The speaker are the one that establish site-to-site EVPN peering, right? And the recommendation is, for each site, no matter if it is a single pod or multi-pod, configure 2 BGP speaker for redundancy, okay? All the other that are not configured explicitly as speaker becomes forwarder. And from an EVPN peering, I only establish geographic EVPN peering between the speaker in the different sites, and then inside the multi-pod fabric, dynamically there are created EVPN sessions between the forwarder and the local speaker, so that these guys in this other pod can also learn the information that comes from the other sides, okay? So it's a hierarchical peering method that is done to minimize the amount of EVPN peering that I do over the geographic network, okay? I leave you the packet walk as an exercise for tonight. Don't go to dinner, look at that. And I want to cover 2 more points that are essentially when I connect, here we go, this one, the tap pools and exchange between sites, right? I already told you, and this is the reason why, actually I told you before, that we don't filter the tap pool advertisement out of the spine, because with multi-pod in this scenario, I need this tap pool to be exchanged between the 3 pods, because in multi-pod we always encapsulate leaf to leaf, which means a leaf in pod 1 needs to know how to reach an IP address which is taken from the tap pool 10.2.0.0/16, right? So these 3 in the IPN, I need to exchange the tap pool reachability between the pods, but I don't want to advertise that information into the backbone. Why? Because it may very well happen that I want to connect now this fabric to a remote fabric which has the same tap pool that one of the pod here has, right? Because maybe it's a fabric, it's an acquisition, or it's a fabric that was independent and now I want to put together in a multi-site architecture. So I want to be sure to go on the layer 3 device here that learns the tap pool and ensure that I don't send that tap pool in the backbone. For one reason, I already told you, that could be that this tap pool is already used in other parts of the backbone, right? So you want to keep your backbone clean. Reason number 2, because if I advertise this tap pool and it comes down here, it may happen that some traffic that from pod 3 needs to go to pod 1 inadvertently goes to the remote site instead, right? And I'm going to pollute my IPN routing table, right? So filter this tap pool at the border between the IPN and the backbone, and at the border between on the first layer 3 device where the remote site is connected, okay? Last point, since I have 2 minutes, migration scenarios. What do we support? This is the most frequently asked question, right? Well, scenario number 1, which only exists on the slides, is you have 2 greenfield ACI fabric, right? With nothing in it. That is beautiful, life is beautiful. I put the multi-site orchestrator on top, I start defining my policy in the templates, and I push that policies to site 1 and 2, or only to site 1, some other policies to site 2. I do everything, it's greenfield, it's a greenfield environment, okay? What is most likely is that you already have an ACI fabric up and running before bringing multi-site into the picture. So imagine I have a site 1 brownfield site that could be a multi-pod fabric that I already have up and running, and now I want to add connectivity to a greenfield site, which is my new disaster recovery ACI fabric that I just built, right? What I can do in that case, if I need to extend, for example, enable IP mobility for SRM, for disaster recovery purposes across the site, I can import the configuration for a given tenant from the local epic into the multi-site orchestrator, build that configuration in a template up here, associate that template also to the second site, and push down back the configuration. At this point, the template with that bridge domain, with that tenant, with VRF, will start existing also inside 2. So I extended the tenant, I extended the VRF, I extended the bridge domain if I want to enable the IP mobility disaster recovery use case, right? So it's totally supported to import policies that already exist in an epic domain and then push them to a new epic domain. The frequently asked question, and is the last point I cover, is what if I have brownfield and brownfield, right? Can I bring the multi-site orchestrator? We have many customers that they didn't want to go multi-pod because they want to have independent fabric, and they interconnected this fabric with OTV, for example. I want to get rid of OTV. I want to do the east-west communication on the multi-site. Can I bring the multi-site in that environment? The answer is probably yes, but you need to be sure that the policy that you have defined in Epic Domain 1 and Epic Domain 2 for the same tenant, for the same VRF, have the same name, right? If in Site 1, the VRF is called VRF Site 1, and the same VRF in Site 2 is called VRF Site 2, the multi-site orchestrator will not be able to import this object with different name and combine them as a single object. But if you mirror the configuration, right, the object names across sites, you will be able to import that configuration from both sides and join them together in a common template, okay? It's not covered here, but it's under the hood what you can actually do, okay? So conclusion, I hope it's clear that multi-pod and multi-site are friends, not enemies replacing each other, right? Depending on the use case, you go one way or the other. Be very careful to examine the requirement before deciding which solution to go for, because once you go, it's a fork in the road, right? If you decide to do multi-pod, if then you say, oh man, I wanted to do multi-site, it's going to be painful to move from multi-pod to multi-site, right? So it's a fork in the road based on the requirements. I hope you understood that one architecture is better than the other, okay? Last thing, reference, let me know, give me your feedback, right? This is the poll is the opportunity to get rid of Max. You want to get rid of me, give me all ones. You want me to continue to do this, give me better score. But more importantly, I don't care too much about the score, I care about the content, right? If you didn't find here something you were looking for, let me know, because we come here for you, right? And I want to be able to change the presentation to accommodate your needs and desires. With this, thank you very much for coming. Have a good evening.